functions. Now when we have defined the continuity at a point and continuity in the domain of a function, let's see few results. 1. Let f and g be two real functions continuous at a real number c. Then, number 1, f plus g is continuous at x is equal to c. Number 2, f minus g is continuous at x is equal to c. Number 3, f into g is continuous at x is equal to c. Number 4, f divided by g is continuous at x is equal to c for gc is not equal to 0. Corollary, there are connected results. Number 5, lambda times f is continuous. And number 6, lambda divided by g is also continuous such that lambda is a real number. Now please make certain few standard results which will help you later in doing the question. Number 1, polynomial functions are continuous over R. What are polynomial functions? a0 xn plus a1 xn minus 1 plus so on an. For example, linear functions, quadratic function, cubic functions, all these functions are continuous over R, means in any interval over R. Number 2, fx is equal to mod x is continuous over R. Number 3, fx is equal to 1 by x provided x not equal to 0 is continuous in its domain. What is the domain? R minus 0. Number 4, fx is equal to greatest integer function x. You know, it has its definition, is discontinuous at the integral points. Number 5, sin x and cos x are continuous over R, and likewise you may write the continuity results for few more standard functions. Now another important result which will help you doing many questions on continuously in a simpler way. Theorem 2, suppose f and g are two real valued functions such that FOG is defined at C, and if g is continuous at C and f is also continuous at GC, then FOG is continuous at C. Now let me take an example supporting this. Let me call it example 4. What is the example? He says show that fx is equal to sine of x square. Here angle is x square. Sine of x square is continuous over R. It looks to be a very difficult question, but it is not. Let me rewrite this as sine of x square as in the form of a composite function f equal to GOH, where hx is defined as x square and gx is defined as sine x. Now first of all, let us see that GOH will give you the same function. Just see this composite function GOH of x. What do you mean by this? G of hx. Now what is hx? Function hx is defined as x square. So it is g of x square. And what is function g defined as? Sine x. So it is sine of x square. So yes, we can rewrite the given function sine x square as a composite function GOH. Now here please note, what is hx? X square, a polynomial function. And what is gx? Sine x. You know, and just now you have noted in your notes that x square being a polynomial function is a continuous function over R, and sine x is continuous function over R. So will be the composite function FO. This composite function GOH is continuous. Why? Again I repeat, h is continuous being a polynomial function, g is continuous being a sine function. So f equal to GOH of x, that is sine of x square, is continuous. So mere logically we can prove such kind of difficult functions as continuous functions. Now just to support or take the application of composite functions continuous. Let me take one more example, call it example 5. Show that the function f defined by fx is equal to modulus 1 minus x plus modulus x whole modulus is continuous over R. Again, we redefine hx equal to 1 minus x plus modulus x, which is continuous. Why? As 1, a constant function, is continuous, x being polynomial function is continuous, and modulus x, you have noted, is continuous. And so should be their sum. So hx is continuous. I further defined gx equal to mod x. And mod x is continuous. Now how do you define fx? Isn't it fx, the given function fx, can be rewritten as goh of x. Just see how. It is g of hx. How do you define hx? Hx is defined as 1 minus x plus mod x. And how do you define gx? Gx is defined as modulus x. So it will be modulus of 1 minus x plus modulus x whole modulus. And now as h and g are separately continuous, so the composite function goh, or the given function fx, is also goh. So the composite function goh or the given function fx is also continuous. As simple as that.